So one of my collaborators in NASA, he got so much interested in biochar, not part of the NASA work, but environmental side of work. They she named it superstar. But it can do so many things. Only thing you need to know what you want to do this. And it's all good things. So if you want to say someone what is biochar, then you want to say that this is a carbon-rich high-density material, mainly consists of carbon, oxygen, nitrogen, and gas. To someone where you don't want to speak too much technical, it's more like charcoal. It contains functional group. You can modify it, make through pyrolysis or hydrothermal. The story comes from Amazon. Right? Terracotta, where this black carbon shows that fertility flows better. The next capacity is better. So now, this is the issue we are talking. How to take CO2 out. Industrials last 3 years added more CO2. To read from people or literature, they say 2 degrees Celsius rise is coming in this many years. And if you bring down to 350 level, you might be able to reduce the greenhouse impact, climate change. So we are already here, 400 drops. If you don't do anything, see the normal trend, right? If you have a graph growing up, and if you don't do anything, you keep growing up. If you start doing recycling and all as a socially aware or responsible person, then we might be able to reduce the growth. There's no way we can bring it down. Right? They start using this waste material for energy and storage, they may slow down. But if you want to bring it down, which is idealistic situation, more realistic is being here, but mathematically you want to show that take biochar, put in ground, take biochar, put in ground. If you can do at that scale, then you might be able to bring it down. Okay, but that's a huge task, but we can focus on it. Whatever waste coming, turn into char or those kind of things. So the idea is that char, this was shown with Dutch fertilizing activity. It's not fertilizer, don't get it wrong. Fertilizer is only NPK. Okay, but it helps fertilizing because it will retain NPK in soil for longer time. So if you are saying biochar is a good fertilizer, technically it's not right. There are many sources we talk. So if you want to do at home scale or community scale biochar, let me see if we have it here. Yeah, making biochar at a low scale, we got. We have demonstrated in gardens and all as our outreach program. You take 2 drums. One drum is out, another drum is inverted. Okay, so this is one drum and another drum, little bigger and inverted. And you create holes here. Okay, and fill up inside yard waste, and then the other side annulus will fill another part, and the create holes that push up air, and you light it. The outer combustion will give heat to inner pressure, which is cut off from here. Not like lab where you cut off totally. There are many pockets, but it's still pyrolysis condition. Run lighting so the gardeners and all. Leave it for 1 hour. First 5 minutes you will see fumes like smoke. But with time, all volatile gone, it will be cleaner smoke. And after cooling, just take it out. You have to put in the garden bag to give carbon sequestration at our community. Right? need any chemicals or anything, but you can do that. So let's see if it works. Biomass, they said, inner and outer vessel, and for solution you see, you can create from the copper a simple aluminum stake, put it there, and that one done. Same thing, this is tabletop. Any aluminum can show it just like that. Just take that and impart it. This is good for small scale gardens or filter. They need 1 kg. And I remember I stated biochar needs 1%, 2%. You don't need 10 kg. In 10 kg you need 1 kg. So there are different configurations. You can be innovative or smart enough to design another way to do that. Light up. If you light up from top, it takes time to get it, so this side is peroxide. If you light up light from top, bottom will struggle for air, so you will be peroxide. That's another thing. This design, light up from top, bottom inside. This is Professor Lehman from Ordinary. Put a lot of focus on biochar. That's how we see, we start to see any counter and anything. So it's one of them. And this is RNO. Carbon return to circulation, how you can do. This is uncharged material you are leaving as it is. What is doing? You leave yard waste as it is, what will happen? Will degrade, and degradation is aerobic or anaerobic. It will have maintenance fluid going on slowly. What you are talking on the wetland and all, it will do that. So remember, methane is 21 times more potent than CO2. Let's say as a responsible community, the HR, then it won't biodegrade. Okay? If it is compost, you slow down. Still good. You compost, nothing wrong with it. Okay? And you turn into char, you put it for a long time. You don't degrade, it will stay. It may run off here and there, it will stay. So biochar will stay long time. How many years? People have shown as much they can study 100 plus years. How much we don't know. This is we did in the garden, waste biochar, very dry, hard. So it depends what kind of waste you are collecting. If it is still moist, like say dry, wood or something like that. And that one things very dry, hard, hydrophobic, all these things. You can inoculate it like compost. It will help. So good quality biochar will look like this. Don't stick your hand. And take it and you can rub it in your hand and stick. Okay? It will be hydrophobic. Water will touch it, but it won't show it. Put in microscope surface, you will see porosity there. You can do microbial things. Okay? Now you want to go higher and then all, you can do metals. Photocatalytic reactions going on there, you can do a lot of things before. Alright? You can put NPK in this course, you can do that, it's a slow release. So there are a lot of ideas, but the simple idea is, as a citizen, we can do this, instead of taking it as it is, in community level, and within carbon sequestration. So how biochar improves soil? Improve soil, water handling characteristics, nitrogen uptake bond, reduce leaching of nutrients because it's retaining. Stored carbon in a long-term stable sink. It's not going anywhere. Reduces soil acidity. How? I will not take it uniformly. Depends on pH. So if you have alkaline pH, definitely it will reduce. Okay, so you can use biochar for tuning pH. Increased soil level of available because of the functional group, these metals will stay, its cationic capacity will improve, so this will stay. Methane initiation will be suppressed, right? And you achieve that. Nitrous oxide emission reduced. Increased soil aggregation due to fungal things. Increased soil microbial respiration because of surface we are providing holding it. Saturated rewarding nitrogen fixation, increased cation excess. This is very important when you put in soil. Cation excess capacity is the index measure. Good for organism. Carbon is conductor, so its working is better. And you can keep adding 2 more. That's why we call it superstar. That's so many environment things. Benefits of jar, you can list it out and keep listing out. They are not harm, I tell you others. There is no harm and no disadvantage. So carbon negative emission displaces, reduces fertilizer use. It's not fertilizer, it will reduce the use because it will retain more. So runoff will be less. And what it takes to make just a pyrolyzer. It's very low tech. You don't need skilled labor for this. But taking HTC, you need to be a skilled handling pressure. And this one, we had a team and we finished that implementation. So quality of biochar is improved. This one you can see on here, my student here, we are showing in a garden in Virginia, one of the city. And for schools we did outreach and all. We made biochar here, double drum system. Cooled it, it's a cement complete pad, so took it out, let for some time. Took some of the samples and we said how water is kept clean, just for school students and all. See clean water, it has biochar and dye. This is sand and dye. Nothing happens, you can clean up. This is very, very fundamental, basic principle. Now you can design this chart for some specific pollutants, do whatever other thing modification. So tabletop biochar, this is from our lab, and this was EPA strength design competition. Okay. This is strength to build and environmental production. And she gave us some money. And it's a national competition. You do work 1 year and they go back. So remember lead issue I was saying. One of the city had a failure on pipeline and lead were coming from pipes. So drinking water contaminated. So we submitted a proposal. We didn't conclude there because we don't know. It's a health issue and also we don't go unless it is proven. But we showed that this can be done this way. So we took some cans. This green aluminum can. Cut it nicely double, inverted aluminum. The step wise, we put YouTube video of that, you can see that in YouTube. And this is for our lab pyrolyzer. We want to keep it in open because the smoke will come. Sometimes we don't our anything more. And we put some yard material nearby, we made our own. Now this is beta filter being used there. Aquaguard beta filter and also they have activated carbon and zeolite. This biochar can be activated to zeolite and it started from the sheet of this. Right? This is a good feedstock, it won't do harm, so always somewhere. It's put in soil or garden and all. We have tested for metal removals. Again, it comes to what application you want. You can do organic pollutants, pesticides, herbicides, trap those. You can do for filtration of those, removal. You can do antibiotics and other things, heavy metals. So we have application of this area, other area. In fact, my first study was hydrochar with uranium removal. That came from my background because I was working at bar, so a lot of uranium different criteria. So we are saying that when we use, so this does it well with revenue and it's published method. So you can use for filtration purpose. Activated, we talk how we can do that, so it's repetition here. Yeah, metal removal, some of the data. This is lead, copper and cadmium. Batch study we did and flow study. Batch study of adsorption we do just for getting an editor. Alright? The flow study activated hydrochar, biochar, almost 100% removal, 2 gram per liter concentration, 1 gram per liter or 0.5 gram per liter. These are high concentration. We don't get this much lead in water. Typically PDA. But for testing, we need the requirement. We did flow system, which is common, water flows and you have it. So we packed sand and biochar packed water. This is also published. And lead, and we did that. It removes. We were surprised. We were not knowing what to do with why it happened so much. But it was fine. Metal removal. Soil application. What it does when you put in soil. Soil bulk density you can change. You are putting fluffy material in soil, so you can change the bulk density. Sometimes you need for compaction and loosening the soil, right? Then if there's an acidity, you can manage heavy metal contents, you can manage organic pollutants, you can manage soil absorption, conductivity, tensile strength, soil porosity, you can change water availability increases, water retention increases, cation exchange, microbial nutrients, so you can see so many things, benefits in soil. Cation exchange capacity for different ones, depending on temperature, it varies, it can do cation exchange. And you can further improve by your donation or sulfur composition. Hydrochar also uses soil management, but I remember I said that hydrochar making it costlier than biochar, so why not? But sometimes you might blend with biochar because this is acidic. So you can tune and just blending or something like that. And it has also shown similar properties. One of what we did that solid fuel. So waste material hydrochar, and I keep saying it's a green coal, good quality. So we wanted to look at how good it is. Okay, so switchgrass we put in temperature in hydroponic condition, and we are looking at green coal or solid fuel. So heating value is the important. That's what we are doing, alright? So heating value, if you do hydrothermal at 200 versus 300, 280 was the optimum, and this heating value is bituminous grade 4. Bituminous grade 4, if you do that, it's 24 to 26. The value anthracite is 30, 31. Bituminous in middle grade, which is used mostly, and it was achieved at 280 degrees Celsius, and we had 29.1 kilojoule per gram or megajoule per kg. Right? So this is in between better than that. So solid fuel is good quality, waste coming up and it's moist. And you want to heating application, blend with coal or have your own charcoal or something like this. And the temperature it will come down to make sense, but it will more carbon. I think first day or yesterday we were talking about carbon black. Do you know carbon black? Look at tires. What is 50% is carbon black? I'm talking about impact. Small application filters, less impact because we have filter only 50 gram, 100 gram. Tires, how many vehicles on road? And they have good percentage of carbon black. And carbon black is made from petroleum products. My first job was carbon black industry. Okay. Started my career in Aditya Group. It was in UP and here carbon black production is a process. So I looked there and saw how carbon black is made, and recently I started why not looking at can we make that grade of carbon blend it, at least even you can blend it and can reduce it, right? So carbon black applications you can say is growing because of vehicle and application. It's not only in tire, it's used in many things. Carbon black. Okay. Printing, stains, plastics, rubber, and other places. Tire consumes almost half of that carbon black we produce. And India is the leader in carbon black production because the honey pillar has that monopoly. So carbon black, you will take a feedstock for pyrolysis, get powder, pelletize it, and then dry it and pack it as carbon black. But this pyrolysis is not what we are talking about, at least 16. Putting the dry, get the dehydrated. They have different grades depending on carbon black properties. They start in 120 and 660 and 850. They have different properties. So our idea is, can we look at biochar or hydrochar at least closer to that so that we can blend it. So we started working on this. I don't have much data on that. One of my students has started. We have some literature on that, and that's the direction we should take. Okay. Another is electrode application. I already talked about it. So biochar can be upgraded to electrode grade by application, and if it is not good. But what we are looking at is capacitance and surface area in electrode. In our lab, we have gone up to 2800 meter square per gram with food waste. Here you can see cell prices 3000, 2000 and all. Capacitance is what you are looking at. You are looking at electrode grade. And it's 300, 400 waste, and we are getting that from food waste. So we have a project from Department of Agriculture. They are doing this. So this one is from vegetable engineering. This one I see from LG residue. So I will stop here to take lunch break, but before that I can take 10-15 minutes of your questions. Try to stay circular, what we have been doing in the right direction in environmental science or engineering, whatever. Contribution is we can be very low and still impact it. So go ahead.
Thank you, sir. Thank you for the nice presentation. Sir, my first question is regarding the hydrochar pH. Are the volatile compounds that decide the pH of hydrochar?
So, feedstock is organic.
Yeah.
Okay. Organic is cellulose, hemicellulose, lignin, or starch. You look at hemicellulose structure, what I was talking, it has branch chain, acetyl group and all. They are getting released in water because of hydrolysis. It's not pyrolysis we are doing in chemical. So they are contributing organic acid, which is making acid. Even sugar hydrolysis is beginning doing that, not just stop, it will turn into lactic acid and other things, acidic compound. So that's what's contributing to the acidity of biochar.
Okay. My another question is regarding carbon black versus biochar. What is the basic difference between these two, carbon black and biochar? If we crush both, what is the basic difference?
So carbon black is produced at 1600 degrees Celsius.
That means the
gravity,
temperature difference is
very high temperature. Biochar is lower temperature, but it becomes your starting material to go to high temperature and gravity. Because your starting material in carbon black is crude oil.
yeah.
Okay, residue of crude oil is used there, not for distillation. The residue goes to carbon black, and that goes to 1600 degrees Celsius. Here you have biochar as starting material, which is renewable carbon. Now you characterize it at high temperature and do some research how to reduce the temperature with catalyst and other conditions. So that's the direction is, we'll see how the results are coming out.
Thank you, sir. Thank you, sir.
Yes, sir. Like you were saying about biochar and heavy metal, biochar is very heavy metal. There is something redox balance changing or just does it interact with heavy metals? That's it.
Yes,
Interact.
because we have a functional group, which is more cation exchange. We have oxygen groups and carboxylic groups and also. There will be many more things going on on the surface. It looks like it's a gas.
Is there anything like redox balance happening?
Normally, what we look at is how much removal happens, what is that, how we get it done, what are the different mechanical reduction into it. Right? Plus edge outwards. It's very difficult to see which one is one going on dominate.
Sir, as you mentioned, is it possible to maintain anaerobic conditions using
You cut off here, so that's what I said. It's not perfectly anaerobic. If you have some air, you lose carbon in form of CO2. Okay, it's not gasification, but you lose carbon if you have some air. That's why it's a maintain anaerobic. You don't lose carbon dioxide. But this is low tech doing yourself. So it's not lab setting here. You remove all oxygen, plus 3 times, so no oxygen. But those you can do in buckets, so inner vessel is covered, not air flow, that is air is already there, but the outer side is heating, anaerobic but not perfect.
and sir, one of the images in that where you showed how they made biochar in garden. In one of the images, it was completely open. Previously, it was quite covered.
That cartoon was not complete, I was missing some slide there. Okay, so we try to make it copy it maybe something. We have the one vessel filling up, filling up. Another vessel we are covering down, but having some force. So such that outer side is one combustion, the inner is cut off from it, not fully cut off from it. There are power systems. But that's one suggestion. You can have a very, we show you a drum there right from top. 5 takes time to go down and start. You can if you look at the different types of fertilizer, record emulsion, you get the quantity.
So the activated carbon that you are synthesizing from that vegetable, would we have to modify it or we can directly apply for early speed tested?
No, that one we just to make activated carbon burning quite further.
So what was its mineralization capacity?
We tested for dye. We are probably just for the surface area created and other index like carbon number and other things for tracking and then
So one more thing is that you have mentioned that slow, fast and flash paralysis. Sir, what was the operating condition for that?
typically pyrolysis we are doing 450 ideal temperature. Okay, we go to up to 600 also. So I don't know which slide we are talking, but it was pyrolysis going to 400. So our lab goes up to 450.
Sir, in one of the slides you mentioned that you get 3 different kinds of products slow, fast from
Yeah, that's conceptually you can do that. That's not experimental data. So if you do fast pyrolysis, basically you are not trying to make biochar, you are trying to make bio oil and oil for water application. If you are looking for biochar, then you go to slow pyrolysis. Then most of these will retain base air, base carbon, so char will get to carbon. Slow means heating rate, how fast it is. fast means you bring something little very fast and then it will go out from the soil. Okay. Slow means over like transition. Slow, give it for 1 hour and then medium is
Sir, like fresh biochar we are putting in soil, mixing biochar with soil, we absorb nutrients like nitrogen. So it will not make plant nutrient deficient. Like it may retain and it will make plant.
so concept is we are growing something what we do in the soil and put some fertilizer. Fertilizer. Now essence of use of fertilizer. What we are calling the rain composting what is how is that? Keeps there longer time. Then not can be run short.
Biochar used to hold for the longer durations. Now
Yeah.
it will hold nutrients also.
Nutrients
So
there.
the plant will grow. At a starting phase, I am
Yeah.
talking about. It may let the plants to deficient nutrients like nitrogen.
Take just anything, it is just direct, so good for storage. When you are like that, activity changes but stays for longer time because the rain passing off, staying there, they're able to do
Biochar, like you said, has properties like fertilizers. So can we mix biochars plus fertilizers? So it
But
will
the time I was saying that come out with NPK in biochar, more like a fertilizer.
our fertilizers that we already have in the market, and we will not replace, we will mix
Yeah.
biochar and the fertilizers. The need of
They
fertilizers.
cannot find it, but somewhere we can slowly there NPK are there and it's not faster. Then slowly
Now economically it is like more preferable than fertilizers. We are looking at biochar. Like, if we talk about farmers, what they will prefer? If we are giving them fertilizers or biochar or a mixture of both of them. Economically,
biochar we call it soil amendment. We don't call it fertilizer.
Sir,
Amendment
but
soil.
I have one question. At this temperature, there is a oxidation or reductions of nutrients if we give the compound like this much temperature, but it chances to reduce or oxidize the L11 nutrients in the biochar. Because there
When
is
you are
a
making biochar, there is no nutrient available. It is not.
okay.
When you made biochar, you put in soil and then you put fertilizer. Think of composting. Why you do composting? When you do our garden, you compost. What it does, you pour it water. Water is very low. Because of force of control. Right? And if you get
So available nutrients are like oxidized in that conditions in biochar. Anything, okay? Because we did the high temperature in an aerobic condition. So available nutrients
yeah, that will oxidize.
oxidize.
We have got biomass itself has some oxygen in that, right? Cut off pyrolysis stops. You will have some gas, but when you heat it, the gas composition is carbon monoxide and carbon dioxide. Like what? That's all. Some nitrogen oxide. that way you can place heavy metal in the product. Sorry.
So does it interfere with the whole process also? So there, as per you said, the most of the part is like removed, but some of might. So it goes to
Not
the
100%.
so it goes to the fuel part.
So fuel, when we go in to do further hydrogen, to make oil, to make fat, we will leave it. Looking at the Biochar,
We will begin with next session by 2 o'clock. Electricity.
yes. So electricity is not primary because it's a secondary source. You produce electricity. Alright, primary means which is available at the place. How much of the energy is in burning coal reaches the consumer has electricity, and I think I discussed that. Don't do anything and stay with conventional, it is 1/3. Now we are trying to improve how we can do so. IGCC concept, carbon sequestration, and then heat integration and other things. So we are trying to. How many people around the world rely on biomass energy like wood or charcoal? Usually cooking. What we use for cooking here? Electricity.
LPG gas.
LPG gas. Okay? I'm talking wood and biogas or wood dung, what we do with cow dung gas. Tell me how many people is still using that? Not India, across the world. Not India.
Most of the African nations, the countries also, they are using, they are relying on wood, and even our village people are, so I think around 2.6 million or 0.5 million.
Any more other place?
Maybe 2.6 million.
Yeah, other guess?
2.6.
Yeah, it is 2.6. Okay? You can think of percentage of people is still using those things because African country, many Asian country, even many part of India don't have right fuel. You see the smoke and cow dung and all we use for that. This product is not made from petrochemical, right? Speak. I heard some answer, but I'm not going there. I just want to see. Perfume,
Sir, rubber.
rubber, yeah, because that's an explorer. How much of the volume of today's car is comprised of advanced plastic made from oil and natural gas? When you say see a car, what you see? What is it made of? Metal and plastic. Metal are just for things, right? Full of plastic. Now tell me how much?
So 25%.
Maybe more. Okay, so let's go on. Next one. Who is the leading producer of natural gas?
US.
US?
1.34 trillion.
Saudi Arabia? just asking.
So maybe Russia.
Maybe Russia? US?
Yes, USA, sir.
Yeah, US and then Russia.
1.3 trillion cubic
Yeah,
meters.
yeah. It's a ramped up lot of production on that, and especially hydraulic fracturing. Using recycled aluminum scrap to make aluminum cans, how much energy you can save? Using recycled aluminum scrap to make aluminum cans again, how much less energy than making new aluminum cans from scratch? So that's why we recycle aluminum can, alright? And it saves a lot of energy. How much?
Sir, 95%.
95%. You're not looking at Google, right? 95%. Why? How aluminum is made? How aluminum is, then you can answer that. It's an electrolysis process, which is electricity, right? If you don't have to do electrolysis, restoration, polishing and all, it's a lot of it. It's very simple. What is the primary application of coal? What is the process of coal transforming into organic peat called? Organic peat. Organic gasification we will be talking about. It's a natural process called gasification. That's all. What is a major challenge associated with nuclear power? Number 2. Yeah. Nuclear power plant makes empty water. Okay. You go more, it's a decent process. You have enormous amount of heat. The heat removal is the big challenge. Any accident happens. Last one was Japan, Fukushima. Meltdown happened because of heat removal cannot match. So cooling water is very, very important. Which of the following statements about the solar spectrum is true? Yeah.
CO2.
D. It has UV and visible and infrared. What is the primary greenhouse gas fabricated with carbon sequestration method? This is kind of not very accurate answer. It's getting more both sides, but we have started with CO2. And over the time we realized methane it is potent, we know that, but we have a lot of emissions because of natural gas. Alright? So that's called fugitive emissions. So pipeline, transportation, emission, and that's much more. Yeah, so it says CO2, but methane is catching up there. Which of the following is a disadvantage of wind energy? The intermittent, right? Wind is everywhere, land is okay, house emission not much. Yes. If you are sequestering CO2, then which of the process converting CO2 in a stable mineral is called? Carbon capture and storage, mineral carbonation, biological sequestration, enhanced oil recovery. Which one? You are making minerals, right? So it's a mineral. These are very basic and simple questions, but good to interact. Which renewable energy source uses kinetic energy of moving water? The process of using plant energy to absorb CO2 into atmosphere is called
Biological sequestration.
biomass energy is considered carbon neutral because CO2 released during combustion is offset by CO2 absorbed during plant growth. Is it true or false? I'll simplify. Biomass is called carbon neutral. Why? If I talk to someone, they will say like ethanol, you burn it and you get CO2 out. It's not neutral, but photosynthesis takes it back. That's why it's called carbon neutral. It's true. Which renewable energy source relies on internal heat? Geothermal. Which one is natural carbon sequestration? The process of capturing and storing atmospheric CO2 to mitigate climate change is called. Is the most widely used renewable energy source globally, primarily for electricity generation. Two main types of carbon sequestrations are biological is the one. Another one, geological, yes. So that could just a refresher and all the things in renewable carbon, carbon sequestration, utilization, the storage, all those things you can link, and there are many ways. Biochemical we studied is easily touch torrefaction, gasification, but generally discussed by focus on those, and we have about 1 hour to try to cover that gasification, torrefaction, and if time allowed, we will do hydrogen also. But there are terms coming up nowadays, it's called NEE, negative emission technology. What does it mean? Negative emission technology. Negative emission technology means remove from the system. Not so. The list of carbon dioxide removal approaches include land management, you can do that. Accelerated weathering, you can do that. Bioenergy, carbon capture and sequestration we talked yesterday. These are negative emission technology. That's what carbon neutral is not enough. We need to go geologic sequestration, near shore coastal approaches. If you look at the coastal region, you see marshland, blue, carbon, all those. We need to protect that also. You don't have to see just land. There are many other places where you can still sequester, right? And there are many approaches. These are called negative, means you are not neutral, you are reducing further. Neutral is not enough. That's what we are looking at the graph. We can do that. There are many things times goes we will try to cover, but these are much more mostly we discussed somewhere or other. Okay. So like biochar, they are carbonized and it has a lot of applications. The other way of this is more on handling, how you handle this. How can we be more efficient? If we are doing pyrolysis, how can we be more efficient? If we are doing gasification, how can we do that? It's kind of pre-treatment technology, torrefaction. which I started yesterday. Torrefaction means roasting, not doing a lot. Just low temperature heating in absence of air. What it does, if you have a wood chips, okay, you do roasting, what will happen? In absence of air, you just heat it. What do you expect? If you have to make wood pellet, let me tell you, and you have sawdust, you want to pelletize it. The pelletization is energy densification for transportation, anything. So if you pelletize it, what challenges you face? Maybe you need a binder, make a nice pellet. Maybe you have to compress more because it's a fibrous material, not fibrous. But if you roast this material, very common word roasting, it's a torrefaction. What will happen when you keep it moisture will go. You are not adding oxygen, so volatiles will go out. Now you got the sawdust or wood chips. It becomes more fragile, right? Created void by roasting. Now press it. Little bit binder may need, sometimes you don't need, depending on what you get from it, and you degree can act as a binder. Now you can pelletize much more. The torrefaction gives you that advantage. Little bit heat treatment helps you energy density. So provides more energy per unit weight than raw wood. Now these pelletized torrefied pellets can transport. There are companies who transport to Europe, pelletize, they are locally, and simply pelletize, torrefied pellets to Europe or many other countries, to different places. Let's say you have a pyrolysis plant or gasification plant. Bringing as it is or pelletized, it is better, right? You can start from a little better situation than the stop. So it's kind of energy densification. Not look very closely, but this is a good technique to densify and store also. Once you torrefy, it doesn't have to get less perishable. So slow heating or roasting of biomass at 200, 300 is rarely 200 more common, 220, 240. About 30 to 90 minutes under inert atmosphere. If you supply air, what will happen? It will oxidize, volatiles will burn, you don't burn. So it's a thermal treatment process, not pyrolysis, early pyrolysis. And if you do right way, 70% of initial rate of biomass and 90% of its energy. Again I say biomass we are looking for heating health. If you are doing anything you want to keep an eye what happens to heating health. If you do torrefaction, you are doing for handling purpose, compaction, pelletization. So we don't want to lose energy level. Volatiles will be lost. So weight loss is 30%, but energy is still 90%. Not so thing. We reduce the weight and we retain the energy 90%. That's a pre-treatment process. Mainly meiosis goes. So typical wood, there are different properties you will see there. Moisture 30 to 60%. Even if you try, it will come 10% of that. It torrefies. Moisture can go down 1 to 5%. Now you transport, you need transport less water. Charcoal is similar. Volatile matter goes down by torrefaction. Fixed carbon concentrates, means volatile carbon percentage. Mass is there, energy density, you see that. Wood has 16, 17 megawatts, you want to 20, 22, 24. So it's there. solvent density, you can see that hydrophobicity, how much water it can retain and all. So these are in number I talked already. If you do torrefaction like this, certain condition, 0.3 mass loss, 0.1 energy loss. And this energy loss they are volatile, so you can still work it and recover some energy. So solid versus 0.9, you see the energy densification how much you need. 0.9 versus 0.7 is 1.3. You don't use a lot of pressure, mostly pressure. You have temperature. Absence of a solid phase, particle size 4 centimeter thickness or something like that. The time is important, 39, because heat transfer takes time. So you need to make homogeneous and do some time. Heating rate is typically slow heating rate, and the color shape will happen. The same thing goes in colors. This is wood. Raw, air dry, bone dry, mildly clarified, medium, and severe. This is how color will change. It's still not fully carbonized. Okay, you have lot of energies here. So advantages which I already discussed, and it is mainly from handling point of view. These are the advantages. If you don't do that, it's bulky material. You torrefy again, densify, pelletize. Moisture is dry and water resistant. Alright? Fibrous pelletization occur, but now it's broken fiber, so you can pelletize. Perishable means leave it, rot and all, don't rot. Waste, valuable fuel, expensive to transport. There is a top process called torrefaction followed by pelletization. It's used in industry power process. So you torrefy and pelletize and you have this kind of pellets nicely extract easy for transportation. Okay. It will have a different pricing versus this pelletization. You see the difficulty pelletization of the chips. Alright? You can pelletize operation. So again I come back to the traveler, and by pelletization you move little distance. Maybe here then little bit. Now it's good for profile. These pellets can be mixed with coal. You can have a set firing also biomass power plants, or you can have a parallel boiler attached to that or directly sourced from the boiler. Use as a fuel in decentralized or residential heating system. Use as a convenient fuel for gasification. I talk gasification article, but if you are starting from raw, it's better to start from torrefied wood, so it's higher peak there, you can go through books can be higher. Potential feedstock for chemical industry, if you want to do extraction, do other things. Substitute for coke in blast furnace also. Same thing I talked already. Carbonization is different. Dyeing, reduction. There are some examples and all I do. How to calculate how much gas and things. So estimating will look like you have a dryer or a fire, two gas, the gas is coming out, you can put that dryer to burn butter and warm air, integration basically. Combustion we already talked about. So let's talk about gasification. It is one of the oldest technology. Pyrolysis is quite 100-year-old. We know how to gasify, but why we gasify biomass. In pyrolysis, we talk why will we pyrolyze? Because if you make oil, you can put in a container. If you don't pyrolyze and looking for oil, then put how much in density can fix in container, now oil. Same way, gasification why we will do. If I tell you okay, coal can be turned into DL, have you heard about that? Coal can be turned into liquid fuel. Can you think about that? Some countries have more coal than oil, but there is a process through which you can turn coal to liquid, CDL. Biomass to liquid is called median CDL. So how can you turn coal to liquid? And then you put in your cars. So you can gasify coal, not burning, not combustion. You do combust CO2. You can supply air but not 100%, only 20-30%. Coal will gasify to form carbon monoxide, hydrogen, CO2, two other gases. Okay? You remember the first day of some reading material or a starting point? I was talking liquid hydrocarbon, which is diesel gas, gasoline, petrol, they are a straight chain hydrocarbons, carbon, hydrogen bonds. So you need to have a liquid which is a straight chain carbon hydrogen. That's what we want to get. Now we are thinking how can they start that from coal. So when you gasify coal, mixture of gases will be. Our target would be get maximum amount of carbon monoxide and hydrogen. Then any gas will come to another step, but how can you optimize to get carbon monoxide and hydrogen in gas mixture? Carbon monoxide and hydrogen together are called syngas or synthesis gas. Now think of why it's important. CO plus H2, which is syngas. Hydrocarbon CH2, CH2, CH2. In gas you got CO, H2. It's not CH2 but only oxygen is entering you. Get oxygen out, it will be CH2, CH2, then you get it. Okay? So this is the building block gas for making hydrocarbon. Carbon monoxide with hydrogen to run to a catalyst 200 to 300 degrees Celsius. Carbon monoxide and hydrogen will start joining together, and now you have to control the reaction, how long it will go, and you will end up making other things like Fischer drop reactions. So that's what used for coal to liquid. Gasify coal, carbon monoxide, hydrogen. There are other gases here, indica, separator, then big clean carbon monoxide and hydrogen. Clean why I am saying that the down the line is catalytic process. And catalysts are sensitive to impurities. So we need clean gas or mixture of carbon monoxide and hydrogen in certain ratio. I'll tell you what ratio also. If you get that right ratio, pass through the day, catalyst at 200 to 300, discovered by Fischer and brought to scientists in Germany, and they said that you can build it to that's how it is. Okay. So that is coal to liquid process, and I gave you one company and yesterday's control, SASOL, and they are being in South Africa, which plant coal to liquid. So the country who does not have that they do coal to liquid. Can we do similarly for BTA, biomass to liquid? So again, biomass is not coal, but it has carbon, lot of oxygen. When you gasify, you will get more CO2 and other things, but we will focus on can we have carbon monoxide and hydrogen in the gasification mixture, which we can purify and Fischer drop and can. Okay. So that is called Fischer drop, gel or. So that's why biomass gasification become important, but this gives you a route to get liquid fuel. Then if you have solid, not pyrolysis oil, you can go directly to get gas. So now the key is how to get carbon monoxide and hydrogen sulfate. Other gases are not of importance, they will come, but they are not of importance. You can see when you are time in studio. Okay. Once you get CO and H2 mixture, let it be from coal or biomass, then you can do so many reactions. This is a building block, one carbon, two hydrogen. You can start joining and removing oxygen, you can do liquid hydrogen. So Fp is one process to set rock. You can make methanol, you can get hydrogen and turn CO to CO2 and get hydrogen. Not a basic reaction. More on chemistry side of chemical, but I am complete to how it is. Methanol, you can join together. Methanol is CH3OH, right? One carbon. You have one carbon. You have oxygen. And hydrogen, do some chemistry, you can get it. Okay? Dimethyl is considered another fuel. Okay? So 2-methyl is methane. So you can join together and get methanol. This sort of synthesis not only for diesel, you can do ethanol also to that. You got carbon monoxide and hydrogen, ethanol, you join further, you can get ethanol also. You can do fermentation of syngas, gas-based fermentation. How many you are doing? When we talk fermentation, we talk about sugar, water. Now you have two gases that can ferment. Carbon monoxide and hydrogen gas-based fermentation, and you can make ethanol. It's a really different process. Biochar and few other companies trying this route for making ethanol. So when you have ethanol making through biochemical platform, through sugar and fermentation and all, why would you use this route to make ethanol? What are the benefits or challenges? For that you need to remember how ethanol is made biochemically, and now you will see that this is the other way of making ethanol. So how ethanol is made? One of two. They have biomass to pre-treat, subject to enzyme, get sugar, and this ferments and you get ethanol. There are challenges, enzyme and other things, but this is the route to take. Now we are saying you can make ethanol use gasification route, carbon monoxide, hydrogen, and ferment it in a gas phase. So why you this way than the other? And there are companies working in both sides. This one is Biochar and few other companies. Other one is solar companies. So when you get feedstock, and this is thermal process. Syngas formed this gasification 700, 800, 900. Okay, so when you gasify, you don't see impurity or anything. Mix the grass, wood, everything you can mix and you can gasify together. Alright? But if you are making ethanol, you cannot design for two different feedstock at the same time. You can mix so many organic foods together and you can gasify that amount. Second thing is, when you are doing biochemical route, lignin is troubling, right? Don't ferment. And that will come like a baggage throughout the train of processing, right? And that much carbon is lost because that carbon is not going in. But when you gasify lignin and everything breaks down to syngas. Now you can increase the yield of ethanol by going this way. That's why, but the challenge with gas-based fermentation is slow. Lack of knowledge is not, right? So this syngas you can use for power generation. You can make electricity out of it. Gas turbines, right? not been steam, extraction. Liquid fuel synthesis can be done. We talked about Fischer product. Lot of chemicals can be made using this one. Methanol is one example. That's it. Hydrochar. If you are doing IGCC or gasification routes, efficiency gets better. Conversion efficiency. So there are plants, they do biomass to BTL. They go through two-step gasification, low temperature followed by high temperature. We try to balance these two steps, and then you have PC synthesis, Fischer synthesis, you have catalytic gate temperature, and you get liquid. This liquid hydrocarbon or diesel has been shown to be dropping. Dropping means heating up and go, no blending required. You can blend it, but these are as good as what you get from other route. These are gasifier. This is one in paper mill. They do gasification, gasifier run for electricity. So gasifier, gas turbine run for electricity is better efficiency than combustion steam route. Okay. See this is what portability gives you gasifier. It can be a stationary, or you can build a gasifier on this truck and you can move around to supply electricity. The same mobile generator. If you remember yesterday I was talking about husk power. They got concept from here. You have a gasifier, rise husk with the heat and get gas, syngas, run for electricity. The leftover material has some carbon turn into a color. You can turn into charcoal or field also, but that's how you do it. Now if you are running a gasifier like that, the ash content is a trouble here because you are heating biomass at 800. Ash means silica, alumina, calcium, other things. They start fusing together, melting together. Alright? They may not melt fully, but they cling, and that can trouble gasifier. So you are looking for the feedstock which is less into gas and ash. And this is one example of whatever generator or community level generator electricity. This one is a pickup truck in US. Okay? So around 15 to 20 years back, there was a competition there. A run truck on gasifier, best coast to Washington DC. Okay? You have a gasifier on your pickup truck or vehicle, and you are left alone, you don't have anything, keep driving, your truck reach goes first. That was a competition. So this comes from Auburn University where I went for PhD. So they participated in that. The idea is you drive on the way, collect wood, gasifier, run, and you are running out of wood, collect more wood, put it here, keep going inside. It's a downdraft gasifier. So we have to fill wood and you have to remove ash, otherwise it keeps it. Okay, and you keep driving. And wood is not a scarce, so you find something right on the way when you are driving. Getting in at the top, the reason is they were taking woods which are high in resins, they do this and other things in their route, and high in ash. So wood quality will matter how good you take it. But there are some people who want to stay solar and other things, they have their cars on this.
Sir, can we relate ash content with lignin content? Will it be, is there any correlation between lignin proportion with ash content?
Then plant grows lignin and other things. And ash comes from pick up from this soil. Right? So grassy material will want to be more than silica and other things. But I have not seen any relation who has done that So gasification, if you look at it, it's a 4-stage process. You start heating, what will happen? Moisture will go out, drying will happen. Right? So first step is drying. This is the gasifier typically. Okay? This is how gasifier will look like a truck or bigger stationary. When you fill air and biomass together, initially moisture will go out, then some pyrolysis zone, then you are feeding air, it will oxidize, some combustion will go on, then this oxygen reduction, and then here you get syngas, carbon monoxide and hydrogen and few other gases. Now I am saying this is gas, but it can come with tar and many other impurities, chloride, sulfur, and other things. Biomass drying pyrolysis, different gases you see, some methane will form, but higher temperature favors more carbon monoxide and solids which will ash, which will have some charring. So it's a complex process. There will be permanent gases. Permanent gases are methane, hydrogen, those gases. And then some tar and some char. You supply heat, you supply some oxygen for conversion. And this is the gas mixture with tar, and CO2 and H2O comes from combustion. Combustion means supplied oxygen is part of oxygen. There are different modes of gasification, gasifiers basically. Updraft, gas comes from top, where we use biomass, and you have air supply from bottom. Different design. This is downdraft, more common. This is cross draft. Why this configuration are needed? Because our target is getting syngas, carbon monoxide and hydrogen, but other things are also common. Each configuration will give us a star. Downdraft has been shown how to fill it. Tar still there, but less than that. So there are 4 different zones in gasification, drying, pyrolysis, reduction and oxidation. By changing the configuration, you play with the zones. How you fill it, how you fill it. Same thing. How complex the reaction, what happens in pyrolysis zone, gasification zone and all. Downdraft gasifier, up to 99.9% of the gas is very base transformation. It's known for base transformation. That's what we cover. Cross draft, not very popular, it's less complex. So gasification reactions you must learn, because we want to control carbon monoxide and hydrogen, right? And if you don't know the reaction, how you control it, how you do it. So biomass, you know the formula. Can we write biomass formula? How? Ultimate analysis and put in a CH form. That's the formula. That will tell you how much carbon monoxide and CO2 will form by material balance equation. Then this is oxygen over here. Now here the trade-off. You want with oxygen or you want to do air. Both way you can do it, alright? If you go oxygen, then you don't see a lot of nitrogen distance. The gas is less inert, more of the what you want. If you use air, you will get nitrogen as inert carrier. So all of you are dealing with high volume. Both have applications, I tell you. But these are the reactions supposed here. Write your reactions yourself. Biomass formula, oxygen or air. These are the components you will see, and you can do material balance and see how much water to form. Okay? You have 4 different zones. So partial oxidation will happen because you don't have enough oxygen, but some oxygen will contribute to complete oxidation also. You have carbon. Water gas reaction changes between carbon monoxide to carbon dioxide. So there is this peak formation. Alright? When you there is moisture and the steam formation. That steam will play with the fixed carbon or carbon monoxide, and you can shift this candidate in a reversible reaction. So you can have this side or this side, carbon monoxide or hydrogen, or you can turn it to CO2 and hydrogen. So these are the controlling mechanism of reaction, how to tune the gasifier. So again, we started with wood or biomass material. We are turning this energy into gas phase, solid to gas. That's what we are doing. Seeing gas we are making. We are not making CO2, otherwise we lose the energy. So we are turning this side to volumetric energy, calorific gas, which is meter cube how much it is. So we are taking this. So if we are using air, the gas coming out has a lot of nitro, right? So heating value or calorific value per meter cube is gas, not solid. It's lower. Again, I say straight what you want to do with this gas. You want to run a truck, pickup truck or electricity, you are fine. Steam gasification is also, you can add steam instead of air and heating temperature. This will be medium temperature. And if you have pure oxygen, you get high heating value. This is a better gas for Fischer-Tropsch reaction. We start carbon monoxide and other things you can control, but not adding it through air. So if you are looking for liquid phase ETL process, this is the way to go. But the trade-off is oxygen is not there. If you are looking for electricity generation, driving car, mobile generator, this is good enough. Air, because we are looking for low cost application and reactions we talk. So these are the reactions, well-known reactions in gasification, and we use these reactions for controlling, tuning the calorific value or gasification efficiency and other. So this is the overall reaction in gasification. If you are designing a gasifier, you need to do material balance. We need to see what temperature and how. So this is biomass. I put X and Y. You know what it will be from elemental elements. Oxygen, carbon monoxide, CO2, H2O, methane, and we will have some CH gases, CH4 kind of thing, and then tar, char, and ash. So the equivalence ratio plays a greater role here. How much oxygen you are supplying? For gasification, equivalence here is 0.2 to 0.25 is the ideal. If you supply more, what will happen? You will move towards combustion, right? So more oxygen, you will move towards combustion. That's not our objective. And if you don't supply enough oxygen, you will move towards pyrolysis. That is also not our objective. So you have to find a sweet spot. Actually, the spot is 0.25 of the quantity. And these are shown here. If you have air, then nitrogen, how it looks like. Where do you get carbon monoxide maximum? And what are the next gas you are looking for? Hydrogen. So you will see that here you get max hydrogen and there you get max carbon monoxide. This point you are looking for. You are running for liquid fuel here. Seeing gas mixture. So the gasifier sweet spot or operating area is this one, and you will control, you know the reactions how to happen. So we answered already. If ER is less, then point to more pyrolysis. Okay? Excessive charge formation. We already answered that if we have more, then we have excessive CO2 formation, not CO, combustion. So a typical range is 0.2 to 0.4, but 0.25 is the sweet spot. Heating value is important. Gasifier efficiency we calculate and gasifier efficiency is how much heating value you are putting to wood and how much heating value you get in gas phase. That's the ratio efficiency. You don't want to boost the whole lot of energies of the gas. So I have given one example. Temperature of gas is important for the moisture content in gasifier. Again, if you have a dry feedstock, gasification is better. Lot of moisture is basically steam and vapor coming in that way. So moisture content versus calorific water is bringing down to it. As content and composition, gasifier plays a role because these acids are going to be high temperature of the gasification done at 800 900 degrees. Okay, so at that time, many of these metals or as contains potassium, sodium, and all they start cooking. So they may form clinker kind of thing, which may trouble operation of the silica. Dark formation. If you have a lot of dark formation, it's sticky thing, you don't want in the reactor. Right? So biomass reactivity, particle size will matter what you are putting in gasifier. If you have a torrefied pellet going to this, torrefaction will be a pellet will break down immediately when you gasify and you have final particle. So your reactivity. Imagine you put wood chips versus torrefied pellets. Wood chips is a hard surface. It will take time, heat transfer will take time, and also less reactive. That's why you say torrefaction is good for feedstock preparation. So porosity gives you more surface area for reaction. Particle size. So gasifier can be classified in different air zone. There are different classification, but these are the three things how you do heat transfer: fixed bed, fluidized bed, or in-plane bed. Fixed bed is put biomass in this gasifier and heat it. Heat transfer is not an issue. You can fluidize, so fluidized bed, and heat transfer is better, gasification is better. In-plane bed means you make it transfer. Have a pipeline heated high and transfer flow it like this. In-plane bed. Fluidization has fixed bed, fluidize, and supply more air in-plane. So these are more common in coal industry, and that knowledge base comes from that. Air gasification, steam gasification, I already found these things. Design of gasifier, fixed bed. Fluidized bed has lot of advantages because of heat transfer, mixing ability, but it brings complexity also. If you have another gas flowing and fluidization, so you are rubbing the surface, erosion, and other things. Now it becomes very good as a gas solid content, but large pressure drop because we are trying to transfer goes partially train in some fall. We are trying to balance the gas velocity to just fluidize the some particle flow in train. So this gasifier, circulating bed gasifier, this is the bubbling goes here we circulate. Coal industry work on this, and this is more efficient than any others. In train flow, again you can have a steam and mass pressure. So now biomass is flowing across. You can make gasification. So coal slurry does in train flow reactors. Coal slurry pass through the high temperature and plasma gasification. These are good for some hazardous waste, mix of so many things, but kind of gasify. Break it down to building block, carbon monoxide. You can do plasma gasification, thermal gasification. So if you are looking for biomass gasification, gasifiers, acid reduction is important, dry feedstock is important, gasifier is important, oxygen or air is important, what ratio you are doing, Then gas cleanup is important. If we are putting a generator here, gas cleanup requirement is not very high. But if we are looking for a efficient or liquid fuel application, we need to clean this gas because down the line it will be cost. So amount of cleaning of gas depends on what application. Co-firing you don't want a whole lot of cleaning. But if you are looking for syngas or fuel cell application, then we are looking for high amount of gas. Technical variant are as mentioned below. Energy balance, yeah, this one I wanted to know. So imagine that we have gasification done, carbon monoxide and hydrogen will come. Okay, clean gas and we are focused on liquid, DTL, biomass to liquids. We want diesel, range, fuel. Then we are focused on this reaction. This is Fischer-Tropsch reaction. What is doing carbon monoxide and hydrogen, they are joining CN plus 2 and then water. So let's put N equal to 1. What will happen? Carbon monoxide plus 2 plus 1 3CH2 and here will say C and 4 CH4 we will end up making methane. We put one more time 2, then it will come alkane because methane is also alkane one time. We will build alkane like this. Okay? But the goal is this is temperature and the catalyst is EPP level of contamination is also challenging in gas. So you have to have a very low contamination, otherwise catalyst will poison and this may not be very. The other thing is important is this ratio. How much H2 versus how much steam. When you put 1, then it was 3H2, so 3 is to 1 ratio. Okay, if you go for alkane, 2 is to 1, the desired ratio for syngas. And you don't get that when you do biomass gasification. So we need to adjust down the line using water gasification or something to get to the right ratio which is good for syngas. So this is more on chemically inside how to do the reactions and all. But I am showing that this is how it's feasible liquid biomass can be turned into liquid. We have a gasifier, cleaning condition, clean gas, and then you get gasoline or diesel range by cracking the product. Fischer-Tropsch in the chain and then cracking and go to the aromatization and other isomerization and you can get the diesel. And these Fischer-Tropsch fuels are tested already compared with the regular diesel. So catalyst is important. These are the catalyst reactants. You will see the iron, nickel are good enough and cost. These are not toxic catalysts. That's why we consider working with platinum and selenium and other things that becomes costly. So this is a commercial process done and most widely used is nickel cobalt catalyst. These are the reactors, releasing gas, catalyst. The basic approach we call techno-economic analysis. For all these pyrolysis and all the process techno-economic analysis are done. This was coming around, this was done for 2020 ton, and the price was coming around $7 to $8 gallon diesel, Fischer-Tropsch diesel to biomass gasification. We will buy. The regular gas price nowadays is in US $3 per gallon. You come back and I am producing $6 per gallon, it's very organic, right? So that's there, this technology is struggling. And the cost centers of gas cleaning is a challenge, gas formation is a challenge, gasifier design is a challenge. So a lot of research people are working gas cleaning, catalytic development, tar conversion, all this. So that's where the technology is. But when there is not think of this pricing sometimes, like I showed you one time in Germany used just for cold to liquid. This was the first power which started with this concept. Okay, so I think we are out of this classification or effects part of this. We covered long range of things today, energy, what else? All the ways, contour and everything. So I don't want to overwhelm it. Digest. Talk about it. We have another 10 minutes. And then tomorrow we have and we have for other sessions today. But I will have to take it. Go ahead and ask. Anything on gasification or refraction?
This rice sauce can be converted into liquid fuel.
Yeah, you can do that. Here the application was electricity. That's what I said. What you want to make. The concept came that this area needs electricity, and here the gasifier comes in. You can buy commercial gasifier. There are companies in Gujarat that sell it in Africa. They make gasifier and they sell it there because a lot of market in that part. They don't have electricity.
This is gasifier.
Gasifier.
You can convert it to liquid fuel.
That's what I'm saying. So if you need electricity, you stop here.
Okay.
If you need liquid here, and you add another train here, that train will be gas cleaning, catalytic bed, temperature and all. Now this is electricity, so they use air. But if you are doing liquid, better, you can still start with gas, but it's better to start with oxygen. So you get cleaner gas, no nitrogen. Nitrogen poisons catalyst. Then down the line when you come, there are tar, clean up tar. So that techno-economics was showing that it's costly and that's why price was high. But sometimes in certain operations, you don't worry about quartz and need this. So that's the option.
What will be the oil content in the rice sauce?
Rice is not all protein and all. And here you are making gases. It doesn't matter what it is inside. It's a carbon, hydrogen, carbon monoxide, what they are not break down. It's a waste management. Have you heard about incineration? Many of the wastewater treatment plant and then want to get rid of waste, they do incineration. Why? So you don't worry about what it forms in between. Just make total breakdown complete. It's like hitting with hammer to the small ants. So this is what break down everything. So what compound it has doesn't matter much. Everything gas composition. So this is a good process for electricity. If you are passionate about renewable energy, you can have your car without gasifier.
Also, we can target to villages.
Yeah, this is first power is help many villages in Bihar. Many still there are many parts. Some parts are so rural that you don't get grids and transformers and all those things. So we know it does just rural. These are microgrid systems. So in African countries they started with cell phones, right? They started with landline and cordless and then, but some part where it was not there, they directly started with cell phone. Same thing. You don't have transmission line and other things to build. Towards microgrid, they directly from solar or this and that. So you can combine this with solar. In daytime you can run electricity on solar and then switch on the gasifier and the balance work. So you can have a community side power plant. Rice grass is one example. You can have other what grasses or what you have. And it's not very high tech. You can train someone to run gasifier. So this is very good business opportunity. I'll tell you two business opportunities. One is torrefaction. See biomass and torrefy pellets you can sell. NTPC, I think government guidelines, don't take it worldwide, there are some guidelines. You have to do 8% of renewable in your thermal power or steel, cement making and all those things. It's government guidelines. So now I know that the startup game, they focused on torrefaction technologies. supply to the company and get the offtake agreement. If I get offtake agreement from NTPC, then we will collect all the trash material, plastic and all those things. Then they get carbon credit, they get money from the business. And it's not very limited business. And I know some of the companies, they are already doing in India because the government regulation came, they have to have 5% or 10% part renewable in public sector, some of the plants, thermal plants and all. So people are rushing to approximately 35%. Anything else?
So, what is the compatibility between purification and pyrolysis?
So, purification is early stage of pyrolysis. We are not carbonizing. We are running at 250. That's why I said roasting. Sometimes we roast off. That's what we are doing. Pyrolysis, we are breaking down, grinding it off. Then it's kind of treat. For restoring, we are doing some prostate, medical, and take it for next day or something else. And then we do pyrolysis. We do pyrolysis again.
To what extent does it prepare for the further process?
What extent?
To what extent does the infection prepare the material for the further process?
Yeah, definitely. It's most of the blood types of pyrolysis is a good of oil because volatile is going to be water. Now it's like LNG and talking about oil, same thing. So oil and utilities are falling gas stage. So if you take the oil and it's a treating kind of hot water. Bone dry means moisture not there. Remove something, bone moisture also. It's dry so much that it's not 100, 150 or 100. There are different kinds of moisture, bone moisture and bone moisture. Normal drying is like over, that is super analysis. So this sector, what I am talking renewable, is giving a lot of idea for if you are interested in entrepreneurship, having your own business, lot of opportunity in this sector. And government policies are supporting this sector. I give you one example. Many combustion, they are making cement, making cable and other things. They are putting plastics and all to the source. You can come with a better option, pellets and other things. Food waste, electronic pellets and then supply. The challenge is making sure you have that much resources around, consistent. Then only you can take offtake agreement. Offtake agreement means I supply this for so many years, this price. But if you don't have that stock with you, then you will struggle your production problems. A lot of business opportunities, a lot of research opportunities. I talked about R&D aspects, what are the research gaps, and I am giving you some business idea also that will take that out. Okay, any more questions? So I leave you for today, and I am here for tomorrow to chat.